Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from a unit Economic Load Dispatch. The name of a topic is Economic Scheduling of a Thermal Plant considering the effect of transmission losses using BMN coefficient. Now, the transmission loss is always denoted by PL. The transmission loss is expressed without loss of accuracy as a function of a real power generations. The power loss is generally expressed in the form of beta coefficient, or this is also called as loss coefficient. So we always used to write this beta, it is nothing but it will be a loss coefficient. Now let's have a start with derivation of this topic. There are few expressions or few assumptions we have to take while deriving this expression. First one is nothing but all the lines in the system, have same x by r ratio, Basically we are talking about here impedance, which will be a same. Next is nothing but all the load currents have a same phase angle. All the load currents have same phase angle. So this is the second assumption. Third assumption that we will consider is all the load currents, I'll write it as all the load currents maintain a constant ratio. It should maintain the constant ratio to the total current flowing through the system, The next assumption that we will consider is whatever will be the magnitude and phase angle of a bus voltage, at each station, or you can say at each bus remains constant. Now why these assumptions we have made? Generally we used to see the assumptions while deriving any kind of expressions, because we should have some constant values. It should not be changed by changing some parameter. So if we want to find it out that values, or if we want to derive the expression, then we need to consider that whatever will be the change in the value, it should be treated as a constant. Here next is power factor at each station, bus remains constant. So what are the assumptions that we have discussed? All the lines should have same x by r ratio, all the current should have a same phase angle, it should have a constant ratio with the total current, the magnitude and the phase angle of the bus voltage at each bus station, it remains constant, and the power factor at each station bus remains constant. Now let us consider a system. I will draw a diagram here first. Let us consider there is a one generator which is denoted by this G1. Here there is a one switch. This will be the other generator G2. Here there will be a switch. Now let us consider this diagram as here the load is connected to this system. So as load is connected, the current flows through this is nothing but it will be IL. And let's say there are k number of lines, so here we have written this will be a kth line. Now how we can give a nomenclature of this figure? So we can say what? Transmission network without, or we can say, sorry, transmission network with two generating station, with two generating stations. So let us consider that there are two generators. First one is a G1, other one will be G2, which will be working at some voltage level, let's say V1 and V2. We should have a power factor, so it is cos phi 1. For generator 2, power factor will be cos phi 2. Whatever will be output of the generator, Pg1 is the output of first generator, Pg2 is the output of a second generator. It supplies an arbitrary number of loads through a transmission network, which is shown in the figure. Now, in order to determine current in any line, let's say if we want to determine a current in the kth line, then we have to apply a superposition principle, and we need to determine the current passing through the line, kth line, that is IK. So I can write it as IK will be equal to what? It will be a current passing through kth line, k number of line, kth line. Now, there is one important thing which is called as current distribution factor. Please see it carefully. What is current distribution factor? So I can write it as the definition of current distribution factor. The current distribution factor of a transmission line with respect to a power source is the ratio of current it would carry. So what is that? It is a ratio of current it would carry. Current it would carry divided by current that the source would carry, current that the source would carry when all other sources, when all other sources are rendered inactive, or in other words we can say that sources that are not supplying any kind of current. Let's say now the current it would carry, suppose we say here this is the kth line, so current it would carry, it is nothing but what? It will be a IK. So therefore, now let us assume from this diagram, let us assume that now entire load current, that is IL, is supplied by only a generator G1. So how we can draw this diagram? Simply we can draw it like this. This will be your generator. This is the switch, so which is going to close. This will be generator, voltage V1, power factor is cos phi 1, output of the generator will be Pg. Here this is second generator, this will be a G2, here power factor angle is cos phi 2, voltage will be V2. If it is closed, then we will get output as a Pg2. So here we are drawing a diagram considering that only one generator is acting and others are rendered inactive. So I will draw it like this. This will be what I can say, this will be your load current here IL, and let's say this is the kth line through which the current flows is nothing but IK1. Why here we have written 1? Because only generator 1 is acting. So I will write it, the name of this figure, I can say this is figure second, where I can write load supplied by a generator G1 only. Load supplied by generator G1 only. Now what is the current in the kth line? So I can say here for this situation, current in kth line, it is denoted as IK1, which is represented here. Now how we can find it out, a current distribution factor? Already we have seen a definition of current distribution factor. What was that definition? Again I am going to revise it. It is what? It is a ratio of current it would carry. Now we are talking about this particular line through which current IK1 is traveling. So current it would carry, it will be what? It will be IK1 divided by the total current, which will be represented by, total current will be represented by IL. It will be IL. Okay. So therefore, in other words, I can represent this as NK1. This NK1, what it indicates? It is current distribution factor. And here we can say IL will be equal to I1 because just only one generator has been acting. So I1 is the current flowing through a generator and which will be reached to the load. So we can say that IL will be equal to I1. Now let us assume the second situation, whenever there will be only a generator G2 will acting alone. So how we can draw it? Again, it's simple. So I can draw it like this. This is your generator G1. Here the switch will be open. Then this will be your generator G2. Now here that switch will be closed. This is your system. And here this will be, you can say, this is the load where it is connected. Load current will be IL. So here we can draw it like this. So therefore, current flowing through this will be IK2 when it is possible, when this switch will be closed. And here I can say it is no current here will flow because it is open. I1 will not be there, but I2 will be there definitely. Here also you can say this will be your I1. That's why here we have written I1 will be equal to IL. Now how I can give a name to this figure? So I can say this is a third figure wherein load will be supplied. Load will be supplied by generator G2 only. So here we are considering that only one generator is acting alone. Now what is a current through a kth line? So here we can say current through kth line. It will be equal to what? It will be equal to IK2. Now how we can write a current distribution factor for this situation? So current distribution factor, which will be equal to, it is represented as NK2, which will be equal to what? Current it would carry, which is nothing but IK2, divided by the we can say the current or the current that the source would carry when all other sources are acting or inactive, or it is rendered inactive. So it will be what? This will be here IL, or in other words I can say that here IL will be equal to I2 because just here second generator has been acting alone. Now because of the assumptions first and the second, whatever assumptions we have seen, first was all the lines in the system have same X by R ratio and all the load currents have a same phase angle. Now the current distribution factor will be real number rather than a complex. There will not be any term of a complex thing. Now let us consider a next situation wherein if both the generators are acting. If both the generators are acting. So how I can show this? I can say this will be a load current IL. Okay, this will be your generator G1, this will be generator G2, voltages are V1, V2, then there will be a cos phi 1, cos phi 2 power factor, then both the switches will be closed, so here you will get output as Pg1, here will be Pg2, because of that current will flow through this, which is, sorry, I1, here because of that current will flow through this, through generator 2, it will be I2, and let's say this will be your again kth line, so I will represent this as IK. So how we can say this will be your next figure? I can say that load which is supplied by generator G1 and generator G2 both. So now what is a current through a line? Now here if you see current through a kth line, it will be equal to IK, and by superposition, as I discussed earlier, by superposition we can say that as now the current flows, this IK is the current flows because of both the generators acting, so I will write it as IK will be equal to IK1 dash plus IK2 dash. Now already we have seen what is the current distribution factor formula. So current distribution factor when only first generator is acting alone is nothing but current it would carry divided by the current when other sources are acting, or we can say other sources will be rendered inactive. So I1, or you can say IL also. And what is the current distribution factor for a second case when only there is a generator G2? So it will be equal to ik2 dash upon I2. So from this expression, now what I can write, this will be your ik. So therefore I can write ik will be equal to ik1 dash, which will be equal to what? I1 into nk1, because I1 into nk1 you will get ik1 dash, you will get this term, plus what is ik2 dash, which will be equal to I2 into nk2. Treat this as a equation number 1. Now, although the current distribution factors are real number, but these values of I1 and I2 will not be in a phase. So we can say let I1 will be equal to, it has some phase angle which is sigma 1, in a polar form we can say, and I2 it will be what? I2 at an angle sigma 2, where this sigma 1 and sigma 2 are the phase angles with respect to common reference. So how we can draw a diagram for this with respect to common reference means what? Let us consider this is my reference axis. So I will take it as a reference. Let us assume that. Now this will be your one vector, what is of I1. Let's say this angle is sigma 1. This will be a second vector, let's say I2, whose angle will be here equal to sigma 2. So this is a source current with respect to reference. Now can we write in a rectangular form? How I can write this I1? It will be equal to what? I1 will be equal to mod I1 into cos of sigma 1 plus j I1 into sine of sigma 1. Similarly, we can write I2 in a rectangular form, which will be equal to mod I2 into cos sigma 2 plus j mod I2 into sine sigma 2. So this is a representation of a current in the rectangular form. Now what we will do, in the equation number 1, whatever here we have derived, in that equation number 1, I will put all these values. So what I will get, I can write it like this. Ik will be equal to what? It will be equal to I1 into nk1. But I1 will be what? I1 at an angle sigma 1. So I can write it as nk1 in I1 at an angle sigma 1 plus nk2 I2 at an angle sigma 2. Because here we have seen in the diagram I1 at an angle sigma 1 and I2 at an angle sigma 2. Now in a rectangular form, how I can write Ik will be equal to, this is your nk1. Now I1 at an angle sigma 1, I can write it in a rectangular form like this. So how we can write it? I can write it as I1 into cos sigma 1 plus j I1 into sine sigma 1. This is a rectangular form of current, plus nk2 into bracket I2 into cos sigma 2 plus j I2 into sine sigma 2. This is a representation in rectangular form, we can say. So suppose if I separate j term, then how I can write it as Ik will be equal to, how I can write it as nk1 into I1 into cos sigma 1 plus nk2 into I2 into cos sigma 2. So here I have make one bracket in which all real terms have been taken, and what is imaginary term, you will get it as, it will be nk1 into I1 into sine sigma 1 plus nk2 into I2 into sine sigma 2. Now what I will do, here I'll draw it a diagram here again. Now we know that what is this j. Now suppose if I take here, please see it carefully. Now if I take it here, squaring on both sides, what it will be? Mod of Ik square will be equal to what? Square of this term. So nk1 I1 cos sigma 1 plus nk2 I2 into cos sigma 2 whole bracket square. Now we know that what is a j square? J square will be equal to -1. But here as we are taking about a mod, so therefore I can write it as directly nk1 into I1. That's why plus is there, as it is a mod has been taken here. Sine sigma 1 plus nk2 into I2 sine sigma 2 whole bracket square. Now we know that how we can write it as a plus b bracket square. Okay, how we can write it as, it will be equal to what? A plus b bracket square. So let me write this now. So therefore ik of square will be equal to a plus b. So it will be what? nk1 I1 cos sigma 1. So I can write nk1 square I1 square cos square sigma 1 plus nk2 square I2 square cos square sigma 2 plus 2 into nk1 into I1 into cos sigma 1 nk2 into I2 into cos sigma 2. So this will be equal to what? This will be a first term, and for second term if I do a squaring, then what will be it? What it will be? nk1 square, this term please see it, I1 square sine square sigma 1 plus nk2 square I2 square sine square sigma 2 plus 2ab means what? 2 into nk1 I1 sine sigma 1 plus, sorry, plus, there will not be plus, nk2 into I2 into, it will be what? It will be sine sigma 2. What we did just here, we have used a plus b bracket square, a plus b bracket square, which will be equal to what? A square plus 2ab plus b square, and here we have taken mod. That's why that j square will be equal to minus 1. This term will not be equal to, we can say, will not be equal to negative. So now what you observe here, if you take these two terms, cos square sigma 1 plus sine square sigma 1, it will be 1. So can I write like this? nk1, okay, into I1 bracket square, because these two are similar things. Sine square theta plus cos square theta will be equal to 1 plus, similarly I will get it as nk2 into I2 square, because cos square, this is your cos square sigma 2, and this will be sine square sigma 2, which will be equal to 1. So the remaining term is only nk2 square I2 square, nk2 square I2 square, which will be taken as a common. So we can take it as nk2 I2 bracket square. Now the question is, here if you see, what common things I can take it as? Here 2 is common, nk1 is common, I1 is common. 2 common, nk1 common, I1 common. This nk2 I2 common, this nk2 I2 common. So I will take it as 2 nk1 I1. Okay, then it will be nk2 into I2. Now here you will get one thing. Please see it carefully. Here you will get one thing. Cos sigma 1, this term, and cos sigma 2. This is multiplied. So cos sigma 1 into cos sigma 2 plus this will be sine sigma 1 and sine sigma 2. So sine sigma 1 into sine sigma 2. So from trigonometric functions, we know that when there is a formula cos A into cos B plus sine A into sine B, then we can write it as, it will be equal to cos of A minus B. So how I can write mod of ik square? What is the formula here? End equation, nk1 I1 bracket square plus nk2 into I2 bracket square plus 2 nk1 into I1 nk2 into I2 into cos of A minus B, means we can say cos of sigma 1 minus sigma 2. So therefore here graphically, or we can say that in a phasor diagram, we can show it like this. This will be your reference. This will be your reference. Then this was your I1. Initially we have drawn this with the angle of sigma 1. Then let's say this will be your I2 with the angle of sigma 2. So if you complete this, then you will get a resultant value of a current which will be equal to Ik. So this is the formula, and here if you see what is the angle here in between, it will be sigma 1 minus sigma 2. So here you got this angle, sigma 1 minus sigma 2. Now Let us consider whatever equation here we have derived this as a equation number 2. Now how we can write, as we have to find it out power, so we should know what is the value of a current first, then we will be able to find it out a power. So I can say the station current is given by, how we can write a station current for, let's say, generator G1, I will write it as I1 will be equal to Pg1 divided by root 3 into V1 into cos phi 1. You will ask me, sir, from where we have written this formula? We know P equal to Vi cos phi. If it is a 3-phase, it will be root 3 into Vi into cos phi. And similarly, we can write a value of current I2, which will be equal to Pg2 divided by root 3 into V2 into cos phi 2. Now, what is a power loss? What is a power loss? So we can say the power loss in kth line will be, the power loss in a kth, it is what? Basically power loss is I square R. It is 3-phase, so we are talking about 3I square R. So which will be equal to what? 3 IK square into RK, which will be equal to what? Which will be equal to power loss, that is PL. So how we can write this formula of PL, which will be equal to 3 into RK. I will keep it as it is. And this IK square, now we did this. What is your IK square? Please see it carefully. IK square was NK1 into I1 square. So I will put it as NK1 square. Now here the term is I1 square, but in the place of I1, can I write this term? Yes. So if you do a square, then what term you will get? Here you will get it as Pg1 square divided by 3 into V1 square into cos phi 1 square. Please see it carefully what I did. 3 into IK square RK. So 3 into RK as it is. In place of this mod IK square, I have written this formula. And here in place of this I1, I will put it this term. And in place of I2, I will put this term. So how I can write? Next term will be equal to what? Next term will be equal to plus NK2 square into bracket Pg2 square upon 3 into V2 square into cos square phi 2. So how we will get it? Because here in the formula we have I2. Okay. So what is the I2? I2 equal to 3. This value Pg2 upon root 3 V2 cos phi 2. So we will get this term plus 2 NK1 NK2, this terminology, 2 NK1 NK2 cos of sigma 1 minus sigma 2. So I will write it as it is here, cos of sigma 1 minus sigma 2. And where here if you see I1 into I2 is there. So I1 you know, I2 is you know what is the value. So how we can write? I1 into I2 is Pg1 into Pg2. Now this root 3 into root 3 will be 3 V1 V2 cos phi 1 and cos phi 2. So we can write it as, this will be equal to what? 3 into V1 into V2 into cos phi 1 into cos phi 2. Bracket complete, and this bracket is also complete. If you see here, we can take these 3 common outside. Here also we can take these 3 common, so it will be 1 by 3. Here also we can take these 3 common, so it will be 1 by 3. So that 1 by 3 and these 3 will get cancelled. So therefore I will write it as cancelling. Here I can say cancelling 3. Take a common 3 from denominator of all the terms. So here 3 common we will take, here 3 common we will take, here 3 common we will take, and these 3 will get cancelled. So what I will get is, I will get this power loss will be equal to what? It will be equal to Pg1 square divided by V1 square into cos phi 1 square, or cos, you can say cos square phi 1, NK1 square into RK plus Pg2 square upon V2 square cos phi 2 square or cos square phi 2 into nk2 square into rk. I just have multiplied this rk inside, and remaining term will be what, 2 into nk1 into nk2, okay, into rk, and whatever will be remaining term is what, pg1 into pg2 divided by v1 v2 cos phi 1 into cos phi 2. So this term you will get it as here of PL. Now if there are L number of lines in the system, then what is the total power loss? So I can write, for L number of lines in a system, we can write this power loss will be equal to what? Summation I equal to 1 to L 3 into IKL square. I square R basically it is. So I square R 3 phase and L number of lines, that's why here we have written it like this. That is how we can write now this formula for PL. So if you refer this above formula, then you will be able to write it like this. So I will write it as, this will be equal to what? This will be equal to PG1 square divided by Pg1 square divided by V1 square into cos phi 1 square. Okay, and here I will write it as summation I equal to 1 to L n k1 square into rk. What I did, just wherever there will be a n k1 rk, before that I have just put summation k equal to, sorry, it is not I equal to, it will be k equal to. Wherever there will be a term k, here before that we have written summation term. So we got this term pg1 square, here pg1 square, v1 square, v1 square, cos phi 1 square. Here before this term we have written summation k equal to 1 to n. So let me turn on my battery first, just a minute. Okay, so here again what we can write for a next term, it will be equal to plus. Now please see this term pg2 square upon v2 square cos phi 2 square. Now here before that we have to write a summation, because if L number of lines we can write it like this. So I can say pg2 square divided by v2 square cos of phi 2 square summation k equal to 1 to L n k2 square into rk plus, now remaining term you have to write these two, pg1 pg2 v1 v2 cos phi 1 phi 2, and before this nk1 nk2 rk, what we have to write? We have to write there a summation term. So how we can write this term as, it will be equal to plus 2 into pg1 into pg2 into cos of, there will be sigma 1 minus sigma 2 whole divided by v1 v2 cos phi 1 cos phi 2. Now the remaining term is what? Remaining term is nk1 nk2 and rk. So I will write it as, with the summation k equal to 1 to L nk1 nk2 into rk. Now if you carefully observe here, whatever this term we will get, let me open other color, whatever term here we will get, this term, okay, I will take this total term from this to this term is called as beta 1 1. As I already discussed with you while starting this derivation, as I already discussed with you that what is this derivation? Transmission loss PL is expressed without loss of accuracy as a function of real power generation. So this is your power loss, this will be a real power generation. So remaining term we will treat it as what? It is a constant. So it is beta 1 1. This remaining term, whatever it will be, okay, this term, this is called as beta 2 2, and the remaining term where we'll get it as, okay, from this to this term. So this remaining term, this is called as beta 1 2. So this above expression can be written as, we will write it as PL will be equal to beta 1 1 into pg1 square plus beta 2 2 into Pg2 square plus 2 into beta 1 2 into Pg1 into Pg2. So this expression is called as, we can say it will be a loss expression. This is called as a loss coefficient or a